sort of starting to structure some sets of funds that would be available for the projects. So this happens to be a phenomenal opportunity from sets of courses that are called Cardinal in terms of taking the projects and field testing them during the summertime. So it's, of course, not all projects will go to that stage. I would like everybody to go to that stage, but it'll be determined by what we do and is it the right time to test out things in the field or just continue working in a much deeper sense over the summer itself. This would be something that's applicable to all teams. So I had mentioned last time a couple of trips and students who were able to take projects to the field. Although the Stanford students would be applying, but it would be applicable to your entire team because at the end of the day, the teams are all working together. So I'm just going to let you do a quick intro for the program, what the needs are, and we might actually schedule this. It's going to be a volunteer thing. I can understand not everybody would want to apply. That's perfectly okay. But we will schedule our project kind of deadlines around submissions, and we'll make one of the proposals as one of the submissions. So the deadline for this will be one of the deadlines where we have firmly chosen our community partners, we have chosen our project, we've chosen our teams. And I think that's roughly around February 10th.
For internationals.
Yeah, or February
3rd.
3rd. Okay. All right. So over to you.
Sure.
And then you should do a quick intro of the broader public the public frontier for Stanford. Yes.
Hi, everyone. My name is Valerie Chow.
And Nico, can you record?
Yeah, I'm recording.
Okay.
Great. Hi, everyone. I'm Valerie Chow. I work at the Haas Center for Public Service on the Cardinal Porter team. Have you all heard of Cardinal Porter?
Actually, can you just define
I will.
Cardinal Porter?
Yes, for everyone.
I've heard it, but I don't think I can define it.
That's the case for a lot of people.
Yes.
The Cardinal Porter is the umbrella term for any funded public service internship opportunities that are 8 to 12 weeks long, full time, usually over the summer. So any program at Stanford that funds you to do a public service internship that is full time is under the Cardinal Porter umbrella. And so I gave you a handout of all of the programs that are under this umbrella. It's really great that over 500 students participate in this program every year. And it's so nice to see so many students willing to do public service when you have other options, and public service is just such an integral part of everyone's experience at Stanford. And so I'm here to kind of tell you a little bit of an overview of what Cardinal Porter is and what programs there are, and then also what would be applicable to this class in particular. So there are two main buckets under the Cardinal Porter programs. There's, like I said, over 500 opportunities, and the Haas Center runs about half of them. So, come over to the Haas Center, get advising at any time you'd like. And so the two main buckets are prearranged opportunities, meaning we have gone out and sourced internship positions for you already, and then you just submit an application to that internship position. That position is already geared and designed for a Stanford student to apply to. And then we have the self-designed opportunities.
Which is what we're excited about.
That's right. So you can go out and find a community partner to work with for full time over the summer. And then we will give you the funding to do that work, because a lot of these projects, unfortunately, are unfunded. And we'd like to encourage students and level the playing field of who can participate in these opportunities. So just really quickly on the prearranged opportunities, just to hire a couple that may be relevant to folks in this room. And most of these opportunities are available for continuing undergraduate students. If you're a senior, don't worry, I have something for you as well. We have a lot of things in the sustainable energy space that would be open to all students, undergrad and graduate students and graduating seniors. So for example, the Schneider Sustainable Energy Fellowship and the Schultz Energy Fellowships, they're both due next Tuesday. And you can work with sustainable energy NGOs through Schneider, like NRDC or Environmental Defense Fund or U.S. Climate Alliance. And then for Schultz, you can work with government agencies in sustainable energy, like the California Independent Systems Operator, where you can, work on the electric grid and things like that. So those are open to everybody at Stanford. If you're enrolled at Stanford, you can apply, graduate, undergraduate. And then other prearranged opportunities would be stuff like Stanford in government, if you want to do a policy internship. And then at the Haas, we have a slew of educational internships or philanthropy internships as well. And then over on the self-design side, the deadlines for that, for the Haas Center's opportunities, the domestic U.S. deadline, if you're staying in the U.S. this summer, is February 3rd. And then for international, it's February 10th. You have a little bit more time to set up an international opportunity. So for that, you would go out and through this class, you will be able to find a community partner to work with over the summer, talk with them about what you would like to do full time for 9 weeks over the summer, and then together kind of fill out an application. So they would have to fill out a very short 1-page description of what you'll be doing with them over the summer. And you will fill out a regular Stanford application for things like this, for essay questions, very short, pretty straightforward, actually. Resume, transcript, all of that jazz. And the funding starts for the self-designed internships at $7,000 base. And then if you're traveling or if you're going to a high cost of living area in the States, including the Bay Area, you'd get an additional $500. If you're on financial aid, there's an additional $1,000 to $1,500. So that is for you to cover your travel expenses, your lodging expenses, your living expenses. We should cover most of it for the summer. A very special fellowship that I would like to tell you about is called the Public Service Projects Fellowship. So for that one, it's going to be a perfect fit for this class. You can get an additional $1,000 for project expenses. So let's say you have to buy materials to build something. You can use that money for that because we at the Hot Center want to alleviate any costs that the community partner may incur in hosting you. So if you need to test something out and you need to buy materials, the Hot Center will give you additional up to $1,000. You just have to give us a budget of what you're going to use that money for, and we'll give it to you. So the application is online, everything's open. It's pretty straightforward. And some sample projects that, folks have done. Last summer, Magnus went home to Ghana and he built upcycled school furniture, like from waste for his hometown in Ghana. So now that school has like desks and chairs that he has built from recycled materials. And then another student went to Peru and installed wind turbines and solar panels there and used the project funding to buy some of the materials needed for those solar panels and wind turbines. So, we're trying to get more STEM students involved. That's why I'm here. But we do have, a lot of opportunities for students of all areas of study and all, years. We have a lot of Frosh gel programs. So please apply if you're Frosh. We're Frosh friendly.
I think the thread from our point of view is this is separate from your project funds that we'll do from the department. The idea is this is a do class, so it's not a planning that we do the plan and we execute in the summer. We're going to be starting projects now. That's sort of just for everybody in general. This just happens to be an opportunity to unlock for funds for potentially testing those ideas in round one. This is going to be an iterative process, whatever you do, whether that happens to be local or outside. I think one of the best examples for that was Vaibhav's trip to Nigeria, and it completely rechanges how you're thinking about it. And this will happen a couple of times before you really hit on something you want to do. So think of it as it's going to be volunteer, anybody who wants to apply, but it just in general, it's a very valuable source. And thinking about working backwards, if you're testing something in the summer, are you ready for it? What pace do you need to operate to actually take something out there to test? And the way we will structure it is just because project teams are across the globe, everybody who would be part of that particular team has a capacity to apply. And, I think there's lots of other funding sources we'll bring online. It'll just depend on you guys have your own selection criterias. If some of the other fundings we will bring online, we will have certain sets of selection criterias. But I think at the end of the day, my intuition is if you're willing to commit time, you will get the funding. That's sort of time is much more precious often in these times. Your funding would be competitive from other people that are applying. Mm-hmm. We also have other ways of moving projects forward. Okay, I want to switch. I think it's our first time meeting in person. Thank you again. Thank you. And then Enrico has the list of online resources.
We'll send the canvas and
Thank you.
And in general, drop by Haas's public center. So it's a very important thing that we all feel proud of. And this current time and moment, it's actually very important that we even understand the operational aspects of how these things work. So if you have the time, drop by.
Yeah, we have peer advisors 11 to 5 weekdays.
So just, I think, understanding how the process works is very important. Thank you for coming for such a short notice. I know I'm cutting you short on time, but I have a ton of agenda because I'm seeing many of the people at the first time. Okay, so while people were trickling in, I'm just trying to remember names. So now I can physically see you instead of a tiny little Zoom screen. So people who haven't just shout out your name and your major just briefly. So
I'm Brian. I'm an electrical engineering major.
and which year?
Sophomore.
Got it. Yeah. And then also mention if you have done safety training in this room. Quick intro.
I'm Shidu Ben. I'm studying international relations. I don't think I've done social training with this.
Yes. And then which year are you in?
I'm in junior.
Okay. And then we covered everybody, just one last person. Yes.
I'm a second year master's in design. I kind of did the safety training. I did the form, but I don't think I've done the actual training.
Yeah.
So
I think safety training is a little bit about actually doing it and feeling safe. So even if you might have on paper, but if you don't feel safe, don't operate anything. It's just the rule of thumb always. And especially we're going to give you a lot of freedom to build stuff. There's a lot of Friday tutorials and sessions we will do where you would have all kind of the parts in place. And so you will feel comfortable building things that other people have designed. And so you don't have to worry about, you can have a very different starting point. And I think this is also the whole point of the entire cohort. And then I'm curious, I know we had discussed on the Ashoka side of the story, if you guys have found a space for all of you, start thinking a little bit about a workspace that you might have. That might be just your own garage. That's perfectly okay if you happen to be part of a lab that is phenomenal. Utilize those sets of resources. But if you really feel you're struggling finding some of the simple resources, like having access to 3D printers, some amount of a soldering station, a place for, I think compute is probably, I'm assuming everybody has access to some compute. Some projects might require wet bench work. So choose it based on projects, but do tell me if you feel that you completely are out of the circle of being able to get access to physical space to work. And I think as teams grow, we'll kind of start building these hubs itself as well. But I do want you to think about that early. Okay, let's dive right in. I think kind of one of the threads I wanted to do is cover in detail a little bit of by the numbers. So I'm gonna do a quick session on that. And are people ready to talk about their by the numbers projects? Yes? Yes, I'm not hearing an overwhelming yes. I want to hear an overwhelming yes. It is what it is. Yes, okay? So I'm gonna have a few people, we'll select a few things only on volunteer basis. And we'll dive in and use that as a framework for projects. One logistics thing I want to do is I want you to start thinking about projects now. I think a lot of what is capable and what you're capable of doing will become clear as the project moves along, because there is a lot of background platforms that we have developed over the last 15 years. So in fact, you are perfectly capable at this point. You're not building all the projects from scratch because there is a ton of platform technologies that we have already built. So, I mean, I'll give you an example on imaging and diagnostics. For the last 15 years, we've been building products around malaria. There's a ton of malaria data we have. There is a ton of tools. So you can come in and use that platform to say, oh, I have an idea in sexually transmitted diseases. I'm going to take this framework. I have the entire code stack. I have the entire hardware stack. It's completely open source. And what you're doing is tailoring it completely to a novel application. So you don't have to be intimidated when you're choosing sets of ideas. I want you to understand. And so these Friday sessions are very important. Although they have not been put on the calendar, they are incredibly important for you to pick up, especially the early versions. Then afterwards, it'll become much more that you're doing your own work for the projects. So I think for Fridays, we're going to pick the schedule. This Friday, we will do a full scope workshop. I'm assuming, how many of you actually use the full scope? Okay, so a few of you have used it. How many of you have it? I guess if you've used it, you have it. Online, few of you have a full scope. So one thing you should do is with Enrico, let's do a shipment. Please send your addresses. So we're gonna ship full scopes ASAP to any address that you give us. And then you will have maybe 10, 15 of them. So you can also implement a community workshop around that. That is a tool, and based on what the shipping looks like, we might do the first training, but your units might arrive a little bit later. So just on the
Okay.
logistics,
Yeah.
let's get address for shipments.
Yeah, I'll send out I can send a Google form in which you can compile your addresses so it's more streamlined.
Yeah, I think let's just do that today. So this Friday we'll do Foldscope as a session. The next one we will do is a platform called Octopi. I'll talk a little bit about that, but it's a general purpose AI-based imaging platform that we built first for malaria. Now with a team, we have actually included TB, then a team in Nepal. We included sickle cell anemia. So it's kind of expanding as a universal diagnostic platform. With many of these vision models, it's become quite easy now. But at the same time, there is a lot of hardware and integration. And so we'll open up that machine and you'll get a chance to look through. So just mark that. That'll be next Friday. And one of the assignments would be is you should read the paper that describes. So if you type Octopi 2.0, you'll find that paper and malaria diagnostics. So we'll cover that platform as another session. And then maybe we might do two sessions on that. One, a very hardware specific session, and the other one, a software specific session. The third instrument, we'll switch to oceanography. And so the third Friday, let's do planktoscope. So that's another thing that you can all read the paper. That's another open source instruments designed for measuring microplastics in the ocean. And again, these are past projects or things that we have done and developed, but it's useful for you to get a sense for thinking about what does it take to build a platform, build a community around it, build a framework that anybody else can actually use. So think of them as case studies, and simultaneously you're allowed to beg, borrow, steal anything you want from these projects to build your own projects. Yes, question.
What time are these?
Let's choose a time. Good point. We could stick with 9:30. How does that feel for this class? Who can do 9:30? Everybody can do 9:30? Friday mornings? Yes. I think it would be super nice if everybody can make it. So Friday, the tentative is 9:30 so same time Fridays. And again, we will record it. But I think there is something really, really fun when you are watching a machine being dismantled. Vaibhav, you're going to do a Foldscope session locally for Ashoka. Vaibhav is acting both as a student, but also as a TA for the Ashoka team. So do a session for Foldscope in person, do a session for Planktoscope in person. And I'm going to try to see if we can ship some parts for Squid. I don't think there is an Octopi at Ashoka campus. But I think you'll kind of get a sense that getting a touch and feel for this is important. I think there's a question from Sia, and then I want to switch to by the numbers. Go ahead, Sia.
Yes. Hi, Manu.
And then
Am I
can you
audible?
just also introduce yourself so we have a chance to remember? Sia, can you
Yes.
hear us?
Yes, I can. Can you hear me?
That's probably the audio.
Oh,
I think it's
through computer audio.
Can you speak, Sia?
Hi.
Yeah, let me just unplug for this.
Yeah, okay.
Yes. Am I audible now?
Yes, we can hear you now. Can you do a quick
Yes.
intro and your
Hi.
question? And then I want to jump to by the numbers.
Yes, I will just switch on my video as well. Um, yes. Hi, Manu. Hi. Hi, everyone. I was not a part of the last class. I actually joined this course very recently because on the recommendation of a friend, actually. My question was, is the Ashoka, I mean, I know that the Ashoka cohort is separate, but can people who are based in Delhi also go for those sessions? I mean, group sessions?
Absolutely. The answer is yes.
Perfect.
Yeah. And then Sia, I didn't catch your intro. Can you do a
Oh,
quick intro again? Where are you based?
yes. So my name is Sia. I was born and brought up in Delhi. I've been here all my life. I majored in economics from Delhi University, and my interest is basically it spans a lot of areas. So I have done a couple of impact projects in mental health, in sustainable development, and currently I am sort of trying to understand how behavioral economics figures into human-centric economics, and yeah, that's that.
Perfect. And I think what I'm very excited about is for the very first time, is it here?
Yeah, it's in next.
What I'm excited about is we have international law, we have economics, we have a much broader cohort. And so I think one of the things you guys have to do is make sure you influence the projects. Like, I mean, of course, you would learn a lot in the sets of things that you're being exposed to, but bring that sense of, for all the teams, not just the teams that you join. So you're kind of representing almost an entire field of thinking. And even though you're not part of that project, when you are constructively critiquing a project, I'm going to look on you to say, what advice do you have for the teams? Yes, comment.
Sorry, quick question.
Yeah.
Since if we're working with like an international cohort,
Yes.
in terms of actually building it, like are we gonna build it and they're gonna build it?
Everybody builds it. Yes, that's the point. And I think this is the whole thing, is if it's frugal enough, everybody should be able to find parts to actually. This is an interesting constraint. It is possible that certain sets of times, a certain component or a part is in somebody else's hand. Half of it is in Germany, half of it is here. That's the logistics you have to handle. But the idea would be is whatever resources we can find, we're going to try to make multiple replicas of it. It's possible that one person has a much better shop, much better sets of tools. We're able to provide sets of tools. There is a lot of work that happens also in code, which is very translatable. Frankly, there is a lot more work happening in building on basic hardware, and much of the intelligence is going in code. So it's kind of an interesting framework between the two. Okay, can you all hear me? Okay, so and now what I'm going to do is I don't want to see that. I'll see that. And I think, yeah, that logistics is something as part of thinking about what does it mean to work on global problems. And this would be a common part of trying to figure out if it's a platform, the platform is shared early, and so that everybody has, say, I mean, I'll give you an example of a big NGO has formed recently because we discovered that we could use Foldscope, which we first developed for education, for diagnosing schistosomiasis. Schistosomiasis is a terrible disease. After malaria, it has the largest burden from the morbidity, mortality on people, but it's one of the neglected diseases, primarily because you get the disease as a child, but you get internal bleeding by the time you're 30, you get urinary cancer, and then 30, 35 is where the mortality hits. And so it's such a stretched out disease, and maybe roughly around 700 million people around the world get exposed every month. And so it's a very large, so some of the schools that we work in, 90 to 95% of the kids are positive. And very recently, I think we'd done 10 years ago, we had done some preliminary work actually in Ghana. But very recently with another NGO in Nigeria, we figured out that we can use the same Foldscope that we're using for education now to do diagnosis in schools. So run it as a screening program in a school where you get all the kids and you test all of them, and then you treat the ones that are positive. So kind of one of the examples for that is that platform for imaging had existed almost 10 years. And much of what the team did is build layers on top of it. So there are certain things like that you will be building your projects on that are very, very common, that have already been implemented. And so there's a fabric of technology that already exists, and thinking a little bit about what is abundant will give you a framework for being able to scale your projects much faster, I think. It's not always true. You can actually invent something completely novel as well to begin with. And then the adoption is a little bit slower, but that's fine. I mean, it depends on the problems that you choose. Yes.
You say 700 million are exposed every month. And if you're exposed, like what are like how many people test positive?
So one of the problems with this as a disease is every water body, so most freshwater bodies in Africa are contaminated. We used to have this as well, but the way we eliminated the disease in the US is you ban people from entering those water bodies. And because water access is an issue, it sort of leads to a point where you cannot say somebody to not drink water, not take a bath, not because that's the only water body that's accessible.
Yeah.
So the problem is we don't have very good numbers on the environmental context. And so one of the projects was really about just understanding where the disease is or where the parasite is. These sets of estimates are based on the abundance in what we find in people. There is a mass drug administration program. Currently, Merck donates a drug, which you all probably heard about in the COVID era, and it was being marketed for all kinds of other things, but it kills these worms. That's given once a year. But then if you get exposed the next month, you still get the disease again. So it's a very interesting case in understanding that you can have a cure. It cures you, but if it's an environmental disease and you get it back again, it's a rhythmic cycle. So it's almost as if you didn't get treated.
Yeah.
That's kind of one of the problems. And then again, I think this is why I wanted to think about some of you who are thinking about diseases. I would love for you to think about projects that link them with climate change, because to a certain extent, and just environment in general, there are certain diseases that you really cannot tackle. We have done everything we can, and we still see the burden rising because we don't understand the environmental context around those diseases. And I think this is true for most infectious diseases. Frankly, now it's also true for many of the non-communicable diseases. A lot of lung cancer is actually related to air pollution. So you could look at this and say, oh, we can diagnose as many people with lung cancer, or you could be thinking about what is the connection and what should we be doing about our air. You're still working in the health space, but you are taking a viewpoint or an approach that's much more non-conventional, because that might require a policy approach to say, rather than, and that would be fair, that you arrive at a problem with a health outcome, or you arrive at a problem with an environmental, or you arrive at a problem with an educational view. It's the same problem, but you're applying a lens that's a little bit different. Okay, so I think I want to transition. I want to say a few things about by the numbers and a little bit to give you guys a flavor that I want this class to be very quantitative. So you need to be thinking about, you'll be working on lots of technical things, but just also trying to understand the ideas of that numbers have impact. It has impact on letting you choose the right problem. It also has an impact on convincing somebody else. I was reading a beautiful piece by a friend of mine about statistics and how statistics has been a powerful tool for policy. It's also been misused. Sometimes numbers are used to lie to people. Sometimes numbers are truly used to convince a problem that everybody was blind to. So there is a lot in by the numbers, and you have to be honest with it. You also have to understand the loopholes. There are lots of times we have to understand that we made assumptions, and it's the best we can do, and then go work back on that loopholes. So it's not a one-way street. And there was a beautiful book that was written by a journalist in India around this notion around COVID, because mortality in India in COVID was being all over the map. And of course, it was a tool to manage people's perception or whatever politics that was happening. And so she documented much of that. And she documented this in this context of what are now called data journalists. And data journalists have to be very technical and savvy about what the sources of numbers are, what kind of assumptions you can make, what kind of mathematical tricks you could apply to make these assumptions. Because in physics, we have developed massive number of techniques to make precise assumptions. but simultaneously, you're also acting like a journalist. So you are understanding the loopholes, and your job is to be able to communicate properly where the gaps are. So I think in your assignment of what you turn final after this lecture, think a little bit about making sure that you highlight the uncertainties that are available. Okay, so I want to show you a few slides just as a warm up. And then most of the time, I want to just discuss one or two of whosoever is going to volunteer to talk about your by the numbers. Yeah.
Stanford cohort is gonna leave in 15 minutes or so.
How much time do we have?
25 minutes.
We have 25 minutes. Okay, we're going to go rapid speed, but I do want to cover something. So get your pencils and papers. Let's see if you can figure out who said this. I often say that when you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the state of science, whatever the matter may be. You guys know who said this? This is a tough one. So this is Lord Kelvin, whose name is actually not Lord Kelvin, it's William Thomson. And of course, one of the key things around was he was responsible for, Kelvin, unit of temperature and things. Around that time, science was becoming very quantitative because people used the word, oh, it's hot and it's cold. It's like, how hot, how cold? Every perception. And Maxwell, for example, did a lot of work. Maxwell wrote the electromagnetic equations. But I'll give you an example in this color. He was very bothered by the idea that you can't put numbers on colors in people's perception. And so if I was to ask you, do you see the same red that I see? Color of this bag. He was very bothered by the idea that I can see a color and you can see a color, but do we agree that we see the same color? We don't actually have tools for that. You could develop independent tools to quantitatively test what color and light is emitting, but that is a different question than people's perception. So he actually made massive studies in trying to figure out, could we quantify, this became kind of psychophysics, so intersection of psychology and physics, and he would make people sit in his drawing room for hours coming up with ways and ideas. It's a very difficult question, and actually still remains a difficult question. But putting numbers is important even in places which have felt qualitative in the past. And I think in the sets of problems domains we'll talk about, this will become quite true. Okay, I want to show this map and see if anybody sort of recognizes what we're looking at. This is London, and this is, to me, I would say, the finest example of data journalism. This is 1854, so I don't know from 1854, does anybody recognize what might have happened? Of course, the name is already there, so that gives it away. This is a map made by John Snow. And this was a remarkable sense of thinking about the origin of public health. This idea that you could be trying to cure individuals at a time, or you could look for the source of the problem. So what this map is people got sick in London, very sick. They were dying. Nobody knew why. He just went around in all of London and tried to figure out in which household, how many people are sick or have had deaths. And he made this map, and you guys see something strange about the map. He also marked, he had an intuition that it could have been a waterborne disease. At that time, we didn't have the Koch's principles. We didn't really understood that much about how diseases spread, but he had a feeling that it's bad water. And then you notice he has mapped out the blue taps where people's water sources come from. And you notice a cluster. And from that data, all he did, which is a very famous, if you ever go to London, you should try to visit this place. He did a very simple act. He removed the handle of the pump. You guys know that pumps used to have handles, right? I don't know how many of you have done that. I'm sure some of the folks connecting online have used a hand pump. And what he did, and it's still, the hand pump is still there, and it's a symbol of public health. And the moment he removed the hand pump, nobody could get water from that, and the disease went away. And I think, this is a very famous story. One of the factors around this was really this notion that you could go about mapping, even for a problem you don't understand. Sometimes mapping and thinking clearly in the context of data could give rise to a solution that you were not thinking about. And I think there's a lot in the story. Books have been written about this incidence and how we use public health data to try to manage and think about problems that you might be tackling that would not be viscerally visible. Yes.
The water example, where are people getting their water?
They just started going to the other pumps, and because these are all local reservoir, they stopped using the contaminated water. Yeah, and I think, at this point, this was a medical emergency. People were dying left and right, and nobody knew why. So this was a temporary solution. Then they have to figure out how to fix the problem. But it was an act in which, trying to protect people, he just went on and went ahead and kind of shut that source down, actually also to prove that this is the source. But much of it was done by just household mapping per se. And I mean, I like this example from a point of view of going back to numbers to search for a solution. Like, we have a tendency that often we say that we know our intuition of how to find a solution. But this is why I want you to do this exercise early, and we're going to do it over and over again. Like microplastics, we'll talk about microplastic. If you cannot tell me where the microplastic is, how do I even believe in any fancy solution to remove it? Where is it? Right? I mean, it happens, we get exposed to it, but what is our largest source of exposure to microplastic? Is it our food? Is it our air? Is it somewhere else? Is it the water that we drink? Is it all coming from the tea that we are making from the tea bags that are now actually made out of plastic that have billions of nanoplastics in it? So unless you can prove a point, it's very hard to pinpoint. And you could build a fantastic gadget to do something, and it might not make an impact in the problem. So I think I kind of like that from that framework, is be thinking about numbers before you even begin thinking about solutions. Okay, since I'm out of time, I'll do this in a little bit, but I want to share a set of a resource that I've really enjoyed recently that's become quite common also in biology. So this was the realm of physics. In fact, Einstein did this thing. I don't know if you guys know this, that there was a huge debate whether atoms exist or not, and we can dive into that at some point of time. And Einstein got rallied up into it, and he came up with 10 different ways of estimating the size of an atom. Completely independent ways, from the size and the color of the sky to how particles look like under a microscope, or how heat conducts itself. And he kept arriving at the same number, and that's how he convinced himself that no, atoms are real. And so kind of this has been a tradition in physics, that you make these back of the envelope estimates, and if your estimates from different assumptions come out to be the same. Now that tradition has also ported back to biology, and there's a beautiful website called By the Numbers that you can type in. If many of you are working on a disease context or environmental context, say you're working, and now, so this is Rob Phillips and Ron Milo. They started this website. They now have books about it. There's a book called By the Numbers that's all PDF, openly accessible. There's a very nice website that I borrowed this from. And very recently on the climate side, they also did Anthropocene by the Numbers, which is a climate and what's happening in climate in the context of numbers. And one of my favorite ones is just estimating how many pigs are standing on the planet. And then you might say, oh, from a meat production point of view, what are the impacts, which some of you have seen. The video that I had shared about, did I share that video? That 1% of Earth in 1 second. That's kind of an example of what happens. But just, this is a fun resource that you guys should look at. Much of this is online. I'm not going to tell you much about it. They did a beautiful version for that in COVID. Let's actually transition to talking a little bit about let's find an example from some of the things that you have all done, and then I'm going to share this resource and this deck separately. And then I want to give you, actually, you know what? Why don't I just share this paper as an example? We'll use this as an example for something that is what I like in terms of, this is a paper that I would love for all of you to read. This is a paper that came out in, I think it came out in Nature almost a couple of years ago, 2020. And the paper is primarily a by the numbers extreme to show a crossover point that's happened in humanity when we have created more things in weight than what nature has created in weight on the planet. And I read this paper and it's just almost hard to believe, but it turns out that the global human-made mass now exceeds all living biomass. And it's astounding to think about when you think of all the concrete that we pour, the plastic that, and it happens that 2020 is the estimated crossover point. And you can ask yourself a questions like, I want to know what is the total mass of all trees on our planet that's included in this. Then you can estimate how many cars we have made, and you can ask a question, do we have more cars by mass than the redwood trees? And it might sound like a joke, but then you can also understand that cars emit carbon, redwoods take in carbon. There might actually be an interesting balance, and that comparison is actually valuable. And so this is kind of, because they do this globally, you can read through the sets of paper. This is sort of a context on the living biomass. And rather than quizzing you all, I'll let you guys read it. I like this as a picture, kind of look at the global biomass, and you notice that plants have 82% of the total biomass. But what's surprising is not that the plants have that, but look at the bacterial biomass. It's a massive number. And compared to, then come fungi, and then come archaea, which most of we don't even consider exist on this planet. This is like a domain of life that's been relegated as if it doesn't exist. It's the third domain of life. And after that come protists that are most eukaryotic cells that nobody cares about. And animals are kind of down here. So that is the animal biomass is actually much smaller. I'm excited because we study protists in the lab. And it's sort of, of course you say animals is something that comes to mind. And then even in the animal, you can think about that fish and insects take over the biggest thread. Then the livestock. So, this is interesting. You can immediately see that fish have a larger biomass than all of the livestock, but only 1% of the protein currently comes for human consumption, comes from the ocean. So you can understand that, oh, there is a potential to be thinking about this, but also we are destroying the ocean pretty rapidly in the way, the reason I was in Chile is we were looking at these salmon aquaculture, and it's very destructive as a practice. So we're doing kind of the slash and burn we used to do in farming now in the ocean. So it starts to give you ideas about how you might be thinking about the kind of problems you want to work on. So this is a very important framework. And I think I'll let you guys read this paper to understand the methods. So I'm going to choose, let's do 2 discussions. Let me stop this now. Why don't the folks in the class go first? Who wants to talk about there by the numbers? Explain why you chose it, run through some numbers and tell me what you came at. Surprise us. And then we're going to do the same thing for people in the class so you guys can get ready. And if people online can stay a little bit longer, we'll kind of have this discussion for a little bit longer. But let's turn this into storytelling. And don't worry, you're not being judged on this. You haven't been taught how to do this. But I am actually curious what you chose to do and who wants to go first. If nobody chooses to raise their hand, I will pick you. So you can go ahead. All right. What was your name again? Chiruben. Okay, so you can just start. Tell us what problem you chose. You have to speak loudly so the people online can hear you.
Okay, so the problem
Can people confirm online that you can hear Chiruben? You know what?
Yeah.
There we go. Yes, you get the limelight.
Okay. My question of interest was, how are people in Nigeria experiencing asthma? How are people in Nigeria who have asthma impacted by air pollution due to VOCs released during oil spills? Volatile organic compounds. So I started by just setting out the assumptions. So the number of people living in Nigeria is 218.5 million, and out of that, 13 million people experience asthma. There's about 822 spills, oil spills in Nigeria every year, but that's a low estimate because a lot of oil spills aren't reported.
Yeah. Can you say that number one more time?
822 oil spills
Per year.
per year.
So just hold the thought right there. Does
And
that make sense to everybody? Like, would you have guessed if I had asked you how many oil spills in just one country? Would you have guessed that? What would people have guessed? Now, of course, you know the answer. I would have guessed 10 or 20, but 820, that means more than a couple happening every single day.
more than 40 or 50% of all of Shell's oil spills in the dozens of countries they operate in all happen in Nigeria.
That doesn't make any
Super
sense.
disproportionate.
Why would that be?
Because the regulation.
And is this offshore oil spills or is this
No, this
inland?
happens inland.
I see.
Absolutely.
I see. Yeah. So I think, I mean, this is kind of one thing that I get excited about. Suddenly, the problem that you talked about, I can see a surprise. And so you've surprised us. Okay, keep going.
Yeah, one of the cities that my aunt lives in Nigeria, if you look up at the sky, it's black. So
But that's more because of air pollution or spills?
I think it's more because of air
Air
pollution.
pollution, yeah.
But that area is also the one where a lot of oil spills are concentrated.
Mhm.
So those spills, 822, it equals to 28,003 barrels and
Mhm.
3,007 tons.
But there's
and-
also literally money being spilled.
Yeah.
You could use that money to make sure the spills don't happen.
And then the amount of the VOCs, like volatile organic compounds released per oil spill, is about 1 kilogram per ton.
Mhm.
And then the amount that evaporate in a ton of spilled oil, so evaporate into the air, is high estimate 0.75 kilograms, low estimate 0.25 kilograms. That makes
Per
per ton.
per
Yes,
ton.
per
I
ton.
see. Mhm.
That makes the high estimate.
And the number of tonnage was, what was the total tonnage?
3,008, and then I
Okay,
have the number
yeah,
for it.
yeah.
So the high estimate for the 3,007 tons would be 2,255.25 kilograms.
Mhm.
And the low estimate for 3,008 tons would be 751.75 kilograms released into the air.
Mhm.
The amount of VOCs necessary to flare up asthma at a low estimate is 400 to 2,200 parts per billion. On a low estimate, and then 2,200 to 30,000 parts per billion on a high estimate. I highlighted some shortcomings are that
Yeah,
most
so
of the.
let's hold it there. So there's a big piece in this puzzle. You figured out how much was spilled in the air. You figured out what the human trigger is. Now, one thing you want to do as a calculation is what is the exposure of a human living, say, in Lagos or any location? Because of course, this would be distributed now depending on where they're happening. So, and one assumption you could make is like all these volatiles are equally distributed in the volume of air. That's a decent assumption to think about for volatile. They spread very, very quickly. You can ask how much air a human breathes per day. That's a super easy assumption to make. You figure out the volume of air that you inhale and exhale, and that way you have a per day dosage associated with it, right? And I think, one thing to try to do is choose the sets of numbers, but kind of hone in. And then, by the way, the person stealing that box is Ross. He's the person who makes all of this place work. And so when we have to figure out special things that we need, we're going to reach out to Ross. And I'm assuming most of you know him from the courses you've taken. Yes. Okay. Thank you for.
Thank you, Manu. Sorry to
swinging
interrupt.
by.
And
No, no, no.
happy to
Okay. So finish your thought. Yes.
So, yeah, I agree. The next thing I had was shortcomings of I guess, my ability to do this with the resources I had. Most of the spills are concentrated in southern Nigeria. So pairing that with already underreported instances of oil spills, it's incredibly difficult to ascertain specific numerical by region information and frequency of spills in varying regions.
Is there a city that has the most numbers? So the reason I'm saying this is when you're thinking about context for your by the numbers, of course, Nigeria was a fantastic place to start because you have connections there, you've lived this, you've thought about this, you've seen this, but narrow it down further to even say, oh, this particular region or this particular state is what I'm going to try to focus on. So when you're starting to submit your final versions for this, and we'll kind of continue this discussion again, because we kind of ran out of time. One important thing is let's start. I'm going to now start the class sharp at 9:30. And that way we kind of gain a little bit more on the 5. So try to see if you can rush here. I know now you're rushing to the next class. If you have to leave, that's fine. And the other part for this for now, anybody online who wants to volunteer and give a 5-minute summary for the problem that they chose. But it's critical that everybody should submit. You're not being judged on it, but what I deeply care about is that the problem you chose and how far you pushed it. So try to pushing this much farther and try to bring it in the domain of health. Like we started with asthma, so think a little bit about people's exposure that might differentially vary. Some people spend a lot more time, like kids. You can choose a specific sub-problem in that, oh, what is the population that's getting highest asthma? And they're spending much more time outdoors. Populations that don't live in air-conditioned homes are spending a lot more time. So the exposure might actually vary per person itself. Try to push it so it can help you think about if this is the problem you want to focus on, where would you put a safety net? Would you stop it at the spill stage? Would you stop it in building personalized filters for people's homes? What would the cost of that actually look like? What would the cost of cleanup for these spills would look like? So try pushing it many different directions. There is no one number that you're after. It is kind of a ground basis for how you want to tackle this problem. Okay, so I want to look for a volunteer online who wants to share by the numbers. So first of all, that was fabulous. I love the problem. And then I think one important thing before you submit is submit your sources as well. If you've used ChatGPT or any other tools, just make sure that you put the sources in place. Like wherever you found those numbers, it's very important to document that because the next person who will be following up on it wants to know the sources. Question.
Should we just submit again on Discord?
Yeah, it's a continued submission. It's not again, remember this is any improvement you keep making, keep sharing it with other people. And I want you to read other people's posts. That's super, super exciting. Like you suddenly learn so much by reading. You are the assessors for each one of the assignment itself as well. So you're making comments, you're the one reading, you're the one providing feedback. So feel free to take somebody's, improve it, play with it. I think this is just a general repository of ideas that I want everybody to create. Okay, I'm not seeing a volunteer online. Who wants to share by the numbers? So since nobody raised their hand, Ashwani, you have the floor. You have 5 minutes. Go ahead, Ashwani. You can unmute yourself. Great. Maybe 5 more.
Can you all hear me?
I saw Ben pass by the way. Oh, yeah. Ashwani, can you hear us?
Yeah, I can hear you. My project was
No. Quick intro first.
okay. I'm Ashwini Sinha. I'm a graduate in civil engineering, and for the past 10 years, I have involved myself in sustainable development and helping low artisans and weavers with the technologies and how they can upgrade themselves in India.
Okay. And then what was your by the numbers that you chose?
Yeah, my project or the by the numbers was on the use of water in the just hold for a sec. I'm just having some. Yeah, my was the use of water in textile or apparel industry. So
Mhm.
what I did, I took just one simple uh, cotton t-shirt, and I just found out what amount of water is used to make just one t-shirt, and you will be
One cotton
surprised.
t-shirt.
Yes,
I love the question. Yeah.
and you will be surprised to hear the number that it's around 2,700 liters just for one t-shirt.
2,700 liters of water for one single t-shirt.
Yes,
That
and
is astounding. You've surprised me.
yes,
Okay, tell me how
and
you got to this number.
it's there. It's actually done by many of the scientists, and I have also worked on this area. So
Yeah.
we have a set rules that this amount of water is used at different processes while making a t-shirt.
And then how much of it is used in growing cotton? Because I know cotton is a very water hungry
Yes,
plant
exactly. It's
versus
60
how
to
much of it is
70%.
used in processing and how much of it is used in kind of the dye side of the story. Like, can you break this down a little bit?
Yes,
Because if
yes,
we were to
exactly.
tackle this, what
Yeah, I have.
subclass of problem would we tackle?
Yeah, I have also mentioned in my paper that I have submitted, and it's around 65 to 75% of water is used in cotton cultivation, and around 10% is
Oh,
used
see,
in
so
dyeing.
65% is already just to grow cotton.
Yes.
We should not be wearing cotton t-shirts. I mean, how are you gonna, that's a very tough problem to solve. Maybe
Yes.
we need an alternative to cotton. Cycle
And
t-shirts.
the other number that will definitely surprise you, that the amount of or the number of t-shirt that is manufactured each year. And
Uh-huh. What is that
you
number?
all can, if you all can
Okay,
guess
wait.
any number.
Don't tell us. No, I want people to guess. Type in your chat how many t-shirts are made per year. Type your guess. Just what do you think is the total? I mean, we know the number of billions of humans. Let's assume 10 billion humans on this planet. How many t-shirts are manufactured per year? I see 5 billion, 100 billion, 10 billion, 200 billion. Okay, so I'm seeing majority of the people are saying one t-shirt per person per year. The estimates are around 10 billion. Go ahead. Ashwini, what's the answer?
No, it's actually 2 billions.
2 billion.
Yes, 2 billions
Wow,
of
it's
t-shirt.
lower. It's much
It's
lower than I had thought.
yes. And so when we
Okay,
multiply the amount of
this is,
liters,
uh-huh,
it comes to 5.4 trillion liters of water, fresh water.
5.4 trillion.
Yes, liters of
Yeah, and
water.
then do you know the number? If I want to compare this to how much water does human beings drink for their
Yes,
survival
yes,
annually?
definitely. Yeah, annually, human needs 1,000 liters of water.
Oh my goodness. So we are spending more water in making t-shirts than the survival for the human
Yes,
race.
and there are some parts. I mean, say more parts
Yeah. Parts of
in
the
the
country
world.
have much higher. Yeah.
Not in the country, not in the country. I'm talking of globally. That there are
Mhm,
some parts uh, in world that they don't even get a liter of water, fresh water, to drink.
mhm. Per year.
Yeah, per day. I'm
Yeah,
saying
per day. Per day. Yeah.
a liter water per day to drink.
Mhm.
So if we just increase the area that we are looking and just we apply it to the whole industry, about 93 trillions of water, 93 trillions of water is used per year
Mhm,
in apparel or textile industry.
mhm.
Hmm. So
And
this is
then
my number.
this includes, I would assume if you were to break this down,
Hmm.
you could break this down into the large scale industries versus the small scale industries. Uh, but I guess the percentage of apparel is all coming from large textile
La-
mills and
Large
large,
textile mills,
yeah,
exactly.
yeah,
So, and
yeah.
this is approximately the 4% of water of the fresh
Mhm.
fresh
Fresh water.
water properly.
Yeah, 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 yeah. This is fantastic, Ashwin. I mean, I think it immediately points to that it would be a phenomenal thread to think about projects. One side comment I want to make is we have looked at cotton for a while now, and especially from the perspective of cotton and its used in menstrual pads and just the lack of growing cotton. If you look at farmers, in India, many farmer suicides are related to cotton failing because there was no rainfall. And
Yes.
one space that we've been working on is making cellulose fibers out of sisal, which happens to be a cactus. So there's a couple of
Yes,
papers that
I
we've
have
written
worked
at
on
this
that.
point.
I
So
have actually worked on that. If you permit me, I would like to say that there is a pineapple pulp,
yeah,
pineapple, and we have made fibers from that too.
yeah, I want a
Fibers
pineapple
from
t-shirt. It'll smell good as well.
Yeah, pineapple,
Yeah.
and actually we have made. We are trying to work on that. We are looking for vegan leathers from pineapple.
Yeah. Yeah. I mean, I think one thing you should do is now this is far ahead that use your by the numbers to go
Mhm.
on and start creating a little bit of a project outlines and ideas around when you do a by the numbers, if it already evokes an interest in you of a project, try to write that down. This
Mhm.
weekend, I'm going to share a template for how to put the ideas board. So an ideas board is an intermediate between final projects and by the numbers. By the numbers is
Okay.
sort of starting to scratch the surface. Idea
Mhm.
board will allow you to state a problem statement as precisely as possible. And
Mhm.
then the projects will be literally a commitment that this is what we are going to try to do. So
Yes.
I will send the template for idea board and Ashwani, but just in general, everybody should then try to use these frameworks to write a very, very specific project description. I'm
Mhm.
looking at the clock. I have to run right now for another meeting. But one thing that
Okay.
you should all do is this is so enjoyable that I'm thinking the next lecture, we just do this because it will seed all kinds of
Yes.
projects. So the next lecture, I'm going to try to get every Friday, we will have a full scope workshop. But Monday, we're going to try to do a deeper dive in by the numbers. I'll cover some content, but make sure that you have all posted. I think this is not, this is one assignment that you all should really, really do because it will firm up your interest in the area that you're excited about. And it'll also firm up a problem statement that you might be able to then devise. And it's perfectly okay if you have lots of holes in these numbers, but just please make sure that you have posted in Discord. We have a channel, right?
Yeah.
Yeah. So just post your name. It's also good for you to read other people's and build upon top of it. Like I'm already thinking about this t-shirt analogy and expanding this analogy in a new light. So you're allowed to take somebody else's by the number and add to it.
Mhm.
Remember the
Yes.
philosophy that we had was uh, and not but. So you are allowed to add if you feel like you want to take somebody else's by the numbers in a new direction. The more you do this, the more practice you will get in thinking about large numbers in light of a problem that you actually care about. And if you have something published in that space, also post that, but post all the resources that you've actually used to arrive at these numbers.
Yes.
Okay. All right. I'm going to say bye now. I have to run. We will catch everybody on Friday at 9:30 for a full scope workshop. And then we will also do a Monday lecture. I think we're going to try to continue. This was joyful. This is now open mic. And you have the mic. Go ahead.
Hi, I just wanted to know for our projects, do we have, since we'll be working over like a 3 month period, do we have a sort of a timeline or certain milestones that we'd like to hit?
Yeah, I think Monday I'm going to share those with deadlines. So we know that we have made project teams. I think these are not deadlines in terms of, these are practical deadlines because we want to make sure that teams have been assigned. I want you to be deeply thinking about lots of ideas, but there is a moment you have to freeze because otherwise you're just in idea generation phase and you don't move to the next stage. So I will share the entire schedule for the course with the specific sets of deadlines. So you know that it's coming much faster than we realize.
Yeah.
And I think I want to accelerate that a little bit. Usually we do teams around mid-February, and I'm thinking by end of January, which is literally 1 or 2 weeks from now, we will have teams and the themes that the teams are working on. You can still be refining your final, what is the actual problem you'll work on, but the cohort of people that are passionate about a project and an idea must actually assemble now. So, but Ian, thanks for reminding this, and Enrico and I will talk about this, and we'll put up a schedule probably by tomorrow or by Friday. Okay, I have to run. I'll catch you guys soon. Thank you for surprising us again, Ashwin and Chidabu, and more on this soon. And start thinking about your projects. Bye, everyone.
Bye bye.
Thank you.